Okay, we're on the back of the notes for part 2. And so we're in section 3 here, which says Permutations and Factorial. The definition of a permutation is an arrangement of the elements in a set. Now, factorial is a type of calculation you can make. For example, let's say we did 4 times 3 times 2 times 1, where you start with a number and you keep decreasing by 1 and you multiply those. An easier way to write that is 4 with an exclamation point, and that's equal to 24. 4 times 3 times 2 times 1 is 24. So the symbol for factorial, we say factorial, is an exclamation point. So if you ever see that, all it means is you are decreasing and multiplying all the numbers together. So if we did 10 factorial, which is a huge number, it's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2, and then you go all the way down to 1. Now, we don't want to have to type all of that. Okay, that's kind of a pain. So what you can do, if you type 10 and then go to the math button right beneath the green alpha key, math, and if we go over to PRB, is probability, and notice that number 4 has that exclamation point, that means factorial, so I can type that. 10 factorial is 3,628,800. That is a huge number. It's 362,8800. So 3.6 million. So what happens, factorial is going to get very big very fast. So how would we use something like this? Well, in number 6, how many ways can you arrange 5 books on a bookshelf? So on a bookshelf, we're going to have 5 spots, and we're going to have to make 5 choices here. Now, when we choose the first book, there are 5 ways we can choose it. So to get the first book, there are 5 ways to choose it. So let's say I make the choice and I put a book on this part of the shelf. Now when I go to put the next book on there, I don't have 5 choices anymore because one of them has already been used. You can't use the same book twice on a bookshelf. So when I go to put the second book on there, so here's the first book, 5 ways to do it, so I pick one of them. When I go for the second book, there are only 4 books left. So I pick one, then there are only 3 books left for the third book, and then 2, and then 1. Now the counting principle says I have to multiply all of these together. An easier way to write this is 5 factorial, and if we type that on the calculator, 5 math, we'll go over to PRB, probability, number 4. So it's 120. And honestly, to type 5 times 4 times 3 times 2 times 1 is not going to be that hard either. So we get 120. So how many ways to arrange your bookshelf? 120 ways. How many ways can you arrange the letters A, B, C? Well, there are 3 choices for the first letter. So let's say I pick a letter. Let's say I pick B. How many choices are left for the second letter? Well, I can do A or C, which means I only have 2 choices left. Let's say that I pick C. Now for my last letter, I only have 1 choice left because I've already picked the first 2. So that's 1. So again, see what happens. 3 times 2 times 1, and that is 6. So there are 6 ways to arrange the letters A, B, C. In number 8, 7 people sit next to each other in a movie theater. How many ways can they sit? Now as you start to see patterns here, 1, 2, 3, 4, 5, 6, 7, you don't have to draw the blanks every time, but I like to visualize it. So let's say you go to the movies and you have yourself and 6 friends, so there's 7 people total. Well, how many ways can the first person sit? There's 7 people to choose for the first position. Now, if somebody sits there, that means there are 6 people left for the next position. and then 5, and 4, and 3, and 2, and 1. And we're going to multiply those together. So an easier way to think about it is 7 factorial. And if we do that, we're going to get, let's see, my calculator just froze here. So 7 factorial, we get 5,040. There are 5,040 ways. I'm not sure what happened with my calculator. I'll try to figure that out as we go here. Okay, so number 9, how many ways can you arrange the letters? So M-A-T-H, four letters, 1, 2, 3, 4 positions. 4 ways to choose the first letter, and then 3, and then 2, and then 1. And so we're going to multiply that out, and we get 24 ways. So that would be 4 factorial. Now, this gets interesting if you do B-O-B. So if we do Bob, 3 letters. So for the first letter, we have 3 choices, and then 2, and then 1. But we have a problem here. And the problem is that 2 of the letters repeat. We have 2 B's. If I write this out, I can do B-O-B, B-B-O, and O-B-B. But that's it. Those are the only ways to do this, because if I switch these 2 B's, it's still the exact same thing. So the problem, if I do 3 times 2 times 1, I get 6. But what happens is I'm double counting. There are only 3 ways to do this. So if you have repetition, if you have 2 letters repeating, I'm going to divide this at the end by 2 factorial. Now 2 factorial represents the repetition. That's going to be the repetition, the letters that repeat for that. So to calculate this, 3 times 2 times 1 is 6. 2 factorials, 2 times 1, that's 2. And then 6 divided by 2 is equal to 3. So if you have repetition, you have to divide that out, or else what happens is you are double counting, and we don't want to do that. So for Hawaii, 1, 2, 3, 4, 5, we have 6 letters. Normally we would say 6 factorial. The problem is that you have 2 A's, and we also have 2 I's. So we're going to have to divide out that repetition. So I'm going to put 2 factorial, those are for the A's, and then 2 factorial again, those are for the I's. If a letter repeated 3 times, we would make 3 factorial, or 4 times would be 4 factorial. Okay, so 6 factorial is 720, if you calculate that. Now this is 2 factorial times 2 factorial. 2 times 1 is 2. So 2 factorial is 2, and then I'm going to multiply by that again, and we get 720 divided by 4, which is 180. All right, let's see. Calculator seems to be working again. So I can type this. If I want to type it in one shot, I can do 6 math and 6 factorial over 2 factorial times, now you don't need the times, you can just type again, 2 factorial. And what we get, there's the 180. Okay, so everything is working there. So we'll do a couple more examples here. Let's talk about deck of cards. You draw 2 cards, so we're going to make 2 choices from a standard deck of 52 cards. So if you count all the aces, 2s, 3s, 4s up to jacks, 10, jacks, queens, and kings, there are 52 cards in a deck. How many ways can you draw any 2 cards? Well, 2 choices. How many ways can we pick the first card? 52. How many ways can we pick the second card? 51. We are assuming that we don't take the card and put it back in the deck. So once you pull it out, it's gone. So 52, but then 51. We're going to multiply that together, and we get 2,652. So if you pick 2 cards from a deck, there are 2,600 ways to do it. How many ways can we draw any 2 aces? Now, any type of card like aces or 2s or 3s or 4s, there are always 4 of those. So if we want to pick 2 aces, to pick the first ace, there are 4 ways to pick an ace. So let's say we pick an ace. For the second card, there are only 3 left in the deck because we already chose one. 4 times 3 is 12. Any 2 clubs. All right, now clubs, hearts, diamonds, spades, those are called the suits. And there are 13 of each of those. And that adds up to 52. Okay, so if we're going to pick, we want 2 clubs. Well, there are 13 clubs to choose from, so 13 ways to pick the first card. So let's say we pick a club, that means there are 12 ways left to pick the second club. So we'll do 13 times 12, which is 156. And how about red cards? So you have red and black in the deck. Half the cards are red, half are black. So if I take 52 divided by 2, we get 26. So 26 red cards, 26 black cards. So we're going to make 2 choices. We want both to be red. Okay, so 26 ways to choose the first red card, and then 25. It's not 26 factorial because we're not choosing 26 cards. We're only choosing 2 of them. So when I get to this space, I'm going to stop. 26 times 25 is 650. When you're dealing with cards and probabilities, this is what we're getting into, is you can start thinking of probabilities. The probability of picking 2 aces in your first 2 cards would be 12 divided by 2,652. It's very unlikely. 12 ways divided by 2,652. Let's do one more problem here. We'll do number 11, and let's talk about the lottery. So let's say you decide to play the lotto, pick 3. Now that means you're going to choose 3 digits. You choose 3 numbers. Now the digits are 0 to 9. And repetition is allowed. So you could pick the same digit every time. You could do 555. How many ways can you do this? Now you got to think here, the digits 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you count that, there are actually 10 numbers here. There are 10 digits. So how many ways can I pick a 0 through a 9? I got 10 different ways to do it. Now if we are allowed to repeat, that means I can pick 10 ways to pick the second digit and 10 to pick the third, because I can repeat. The counting principle says we're going to multiply, so we have 1,000 ways to do the lotto pick 3. 1,000 different ways that you can do that, permutations. But what if repetition is not allowed? What if you can't use the same number twice? Well, now we have 10 ways to choose the first number, the first digit, but once you pull that, you can't take it again. It's gone. So for the second number, there are only 9 ways left to do it. There are only 9 digits left, so we pick that number, and then there are only 8 ways left to choose the third digit. So if you can repeat, then it's 10 ways each time. But if you're not allowed to repeat, then what happens is it's going to go down by 1. 10 times 9 times 8 is 720. That's a significant difference. So just by changing this one rule, you have a much better chance of winning this one than this one. Because if you pick one ticket, for example, your odds of winning are 1 over 1,000, where this is 1 over 720. It's still small, but this is a better probability for you. And that's the end of the notes.